When this will come down, that time it will take the V shape. V shape आएगा. That time mode is open. Now the mode is closed condition, because now it form as a that complete I structure. See now here the piston is now up. It is a straight structure, straight. Both links are straight. When this will come backward direction, that time what will happen? There is a V structure like this, and this mode will open. कितना ओपन होगा? बस जितना जितना लिंक है उतना ओपन होगा, राइट? This is also one drawback here also. Therefore, you should understand a single toggle system, friend. But here you cannot measure the force, clamping force. See again here a direct force applied. See direct force. You cannot measure this force. इधर कितना फोर्स है? ये जो प्लेट अभी प्लेटन जो क्लोज किया है, इसको क्लोज नाउ, at what pressure it is closing? We don't know. We cannot measure force here. Here हम लोग force measure नहीं कर सकते. And therefore, here also a direct force, you cannot measure this force also. Many times, if you see here, friend, when you open, now see the mode is closed now at close condition. Here, the clamping is more difficult. And many times, due to this mechanical force, here is at the middle, there's a lot of forces there. Lot of force. And many times, this platen may be bent. This platen may be bent because of this direct force. We do not know how much force is there. Therefore, there is maybe wear and tear systems. Deflection of the platen will be take place. Here, more lubricant required. Lubricant, because it should be, move smoothly here. Therefore, more lubricants required here in this case. Now, what is the advantage of this is that low cost and lower horsepower needed to run. Low cost. If you see that these machines are cheaper than the direct hydraulic machines. Secondly, the require that electricity or horsepower is less here. And if you see here is the only positive plan of the mode. The friend, this is the advantage of these single toggle systems. See now, again, we have seen here a single toggle. Now there is a double toggle systems. If you see double toggle here, double toggle means, see now here a pivot is here. It is also a pivot, right? See it is joined. See there are links. How it is joined here? Two links, this and this. Here is also two links, this and this. And see here is the cylinder here, actuating cylinder. Now when this will go back like this, the mode will open. Now it is now straight. Therefore, mode is now in a closed condition. See, this is stationary platen, movable platen. This is a mode here, all right? And these are links are there, mechanical links are there. If now this pivot with the cylinder will goes, the piston will goes backward direction, what will happen? This will make a V structure here like this, and here also V structure like this. See now, this is open condition of the mode down. This is a closed condition of the mode. At the time of closing, see now V is formed. See, V is formed. At the time of opening, see, it is straight. It is also straight. Now, what is happening? What are the drawbacks here? Which may ज़्यादा force, it is a very force, center force, and therefore it may be deflect. Now, this cannot overcome here. Here, whatever the drawbacks can be overcome by this double toggle system. They are given at the upper and lower level, bottom level, the forces. and hence it has some advantages over this. Second thing, you can take a maximum, that load here. You can fix here a big mode here in this case. But again, you cannot read the force because again it's a toggle system, direct force, locked. अपने को पता नहीं कितना, how much force here, we don't know because these are mechanical links. Now see, mode is closed here, right? Now see, it is opening of the mode. The V structure is saying that it's the opening of the mode. So friend, we have seen the manual clamping, single toggle clamping, double toggle clampings are there. These machines are also available in the market because if you see the cost of this machine are less, but this machine require a lot of maintenance because this you have to lubricant, you have to add every times, and the machine should be, it should be worked there properly, smoothly machine, and the sound will be there because these are opening and closing. Therefore, some sound will be produced there, and maintenance cost is thoda high लगता है इधर friend. But the machine is cheaper than the direct hydraulic machine. Okay, many the machine manufacturer, they still using this type of machine, direct single toggle and double toggle. This is for a small volume, this is for large volume. ज़्यादा बड़ा article है तो you can use the double toggle machine, single toggle for small articles. Now, then they developed these toggle systems, single toggle, double toggle. It is not working properly. There are many, that drawbacks. Cycle time is also high, and many you will not get a proper article, or you cannot measure the clamping force, friend. Now, see now here, in this case, the clamping pressure you can now measure here, friend. This is a direct hydraulic clamping system. This is one of the best, all over the world, the people have accepted direct hydraulic clamping systems. What are the advantages of this? See now here, fixed pattern. Nozzle is there. There's a 1, 2, 3, 4 tie bar. Movable pattern. Move hota hai like this. Second thing, mode here, core and cavity. See, this is a cylinder and this is a piston. See, or plunger. It's a plunger. It's a cylinder. ये ऑयल का, इसमें ऑयल होता है बैक साइड, ऑयल. यहाँ पे सिलेंडर है, पिस्टन है. When the oil go here, that this piston will come forward. When the oil go backward, that time this piston will go backward, like that. See, it is a double plunger, that actuating plunger system is there. Now, the removable spacer is there. Spacer they are adding now. You have seen yesterday in the video also spacer. The tie bar is there, friend. Tie bar. Then this is a fixed pattern here. This is a fixed pattern here. This is a movable pattern here, friend. Now, how when this oil, the force here, but that time this plunger will come forward, but plunger is joined to the movable pattern. Movable pattern joined to the that hub mode, as a core mode, right? Therefore, here is a no toggle system, no link is there, friend, not a single link. Now, how can you measure the clamping pressure here? Just putting here a pressure gauge. यहाँ पे pressure gauge लगाओ, कितना oil force करता है, that you will get here only, right? Therefore, clamping force we can measure here in this case because it is the direct parallel, completely uska parallel force se you can measure at what speed the oil is passing inside, right? Therefore, here we can measure the clamping force. This is the only machine we can measure the clamping force. Direct hydraulic. Direct hydraulic means the oil used here, friend, as a fluid for the moment of. Now see, the lubrication is here, the automatic, because you are using this oil here, and low maintenance, machine will go smooth, cycle time is very less. There are many advantages of this. A clamping unit, see here, a clamping unit actuated by the hydraulic cylinder, which is directly connected to the moving platter. In this case, ram hydraulic system attached. Therefore, there are two half hydraulic cylinder here, which is actually इनलेट एंड आउटलेट ऑफ द ऑयल. यहाँ पे इनलेट दिया हुआ है, दिस इनलेट, दिस आउटलेट, यहाँ पे आउटलेट है ऑयल का, राइट, एंड द सिलेंडर एंड पिस्टन इज देयर फ्रेंड. When oil goes to the cylinder with the pressure, it pushes the ram. This is the ram actually. The plunger bolo, ram bolo, piston bolo, एक ही है. It pushes the ram to forward direction. Therefore, the moving platter moves and mode close here. This moving platter move here and the mode close. And when oil comes from the cylinder, when this oil go down from the cylinder here, or maybe here, this side, the ram come back. This ram will come back. And mode is open. The mode is open. The frame, what are the advantages of this machine? I told you, what are the drawbacks in the toggle system? That all drawbacks can be overcome by this clamping method or system. Clamps speed easily controlled. See, this speed is easily controlled. If you want, see, when the mode close, how the mode close? Can anybody tell me? How the mode close? Can anybody tell me? Hello. See this movable pattern, when it is coming this side, when the mode close, how the mode close? What is the movement of this movable pattern? ये कैसा मूव होता है? Can anybody tell me, friend?
Linear movement only, sir.
Yeah, it is a linear. But see the speed of the speed of this movable pattern. Now, when the mode in open condition, now mode has to close. Okay. Now we have to start the cycle. What thing will happen here? The mode, this movable pattern.
Actually, in a lever, sorry, in the link type, not that last this thing, it will go to the rest position at the back. In hydraulic, we can station very close. Anywhere
Yes.
we can station the moving plate.
Correct. You are right, 100%
So,
right. See, generally what happens,
movement
friend?
time can be reduced.
Correct. See here, we can just move slowly first, then fast. Then when it comes here, then slow again the slow speed. Right. Now, while the opening also, first will go, come here, then again fast, and again it will go here, slowly. Therefore, while closing mode, slow, fast, slow. This type of action will be there. When the opening mode, slow, fast, slow, like that. This is a moment of the movable pattern frame. While closing, slow, fast, close, slow, and while opening also, slow, fast, slow. This is actually we have to adjust by limit switch, which is present there, friend. We can easily adjust this thing, the moment of the movable pattern. Otherwise, एक ही स्पीड में आएगा तो इट विल डैमेज दिस, ये मोड भी डैमेज हो जाएगा. We don't want same speed here. Suppose ये 40 स्पीड में आ रही है ये movable pattern, it will damage here. Therefore, we have to reduce the speed. Initially, start with 5, 10, like that, and then 40, then again slowly 10 and 5, like that. Therefore, friend, I told you closing speed and opening speed. Therefore, here we can control the moment of this pattern, right? At any point. At any point. We can also accommodate the larger mode here. ये हम और भी पीछे ले सकते हैं. We can large mode, we can here, we can keep here. But in this case, see now here, इतना see कितना, बस ये इधर ओपन हो जाएगा तो ये यहाँ तक आएगा. This will come here only. And therefore, the mode height, we cannot accommodate high here. Therefore, only for lower mode. Right. Here also the same thing. You cannot accommodate the huge mode, large mode height. And therefore, this drawback can be overcome by this direct hydraulic machine. Now, second thing I told you, direct readout
Sir,
of the.
recently we got Shiburo mission. In that, we have an LVDT also available. Actually, die has to be opened for 30 mm only first. Then the hydraulic core has to come in. Again, it has to go for another 30 mm. Then the another hydraulic core has to pass in. Then the actual mode closes. Again, return also we can stop in between. And in recent mission it is available. Old mission it is not there. But in recent mission with the knuckle, this thing joint, it is possible in recent.
Yeah. It is a macro processor machine. Correct. You are right. Now it is a microprocessor machine and that will work like that only. Okay. At any point, you can stop this movable pattern. And we can accommodate very large mode here. Okay.
Yeah, yes. Large mode.
Yes. Now you can measure the pressure. I told you pressure हम लोग measure कर सकते हैं. But ये toggle time में pressure you cannot measure. Clamping pressure हम measure नहीं कर सकते. And here the no sound आएगा नहीं आपके पास. So friend, easy to address the clamping force and easy to mode setup. Low maintenance as a part is self-lubricated. It is a low maintenance required. What is the disadvantage of this direct hydraulic? It is a higher cost and more expensive than the toggle systems. Yes, you have to pay some higher amount as compared to the toggle systems. And here, non-positive clamps. Here, positive clamps are not there. That is also one. What is the positive clamp trend? Hello? Can anybody tell me what is a positive clamp? See now here, suppose this mode is closed now. Okay. Now here, see the force, we don't know kitna force hai. How much clamping force, we don't know. But it is maybe 120. 120 रहेगा. ये force 100, जब ये open रहेगा, जब ये straight हो जाएगा यहाँ पे, when this link becomes straight, that time, no, we don't know force, but it is a positive force. Complete positive force, complete positive locking here, friend. Now, this positive force maybe 120 ton, 120 tonnage रहेगा. But it is a constant there till injection, till the mode opening. But in this case, the pressure is here, the clamping, the oil coming here like this. And it will not give the constant force. Suppose आपने को 120 force चाहिए, but it is a 120, 119, 118, 117, 118, 119, 120, like that. The force may be vary as per the speed of the oil, not constant, and that's why now in positive, non-positive clamp. Here the clamp, जो force है, it is a non-positive. वो 120 है, 120 नहीं रहेगा. थोड़ा आगे पीछे plus minus, it will be happening there in a direct hydraulic systems. Are you getting me, friend? Hello?
Yes,
Hello?
sir.
Yeah. This is also one drawback of this. पहला drawback, costly. A second drawback, constant 120 ton clamping force चाहिए तो नहीं रहेगा. 120, 121, 119, 118, 117, it is possible. But not 100% constant till the injection. It is not possible. This is the drawbacks of this. There is only one drawbacks, but that can be, overcome. Now, we have seen the difference between hydraulic and toggle type of systems, right? Hydraulic, I told you that now just this is a hydraulic and this is a toggle. Okay, toggle clamping. Now here the difference is given much higher original cost. Yes, lower original cost. Higher horsepower needed, therefore more expensive to run machine. Lower horsepower needed because the very low, more economical machine to run. Non-positive clamp that just we have seen. Non-positive clamp. The force varies here, right? Here positive clamp. So because the mechanical links are there. Here unlimited stroke possible. कितना ही बड़ा मोड़ डालो, कुछ nothing will happen. Here limited stroke. बस जितना मोड़ है उतना ही बस. If you increase the height of mode, this machine will not work. Not possible to load the mode there. Now, direct readout of the clamp force. Yes, हम लोग clamp का force readout direct कर सकते हैं. Right, by pressure gauge लगा के. But here no direct readout. Pressure you cannot, clamping force you cannot measure here. Easy adjustment of a clamping force. Yes, we can easily adjust clamping force. More difficult. Possible नहीं है. एक बार लॉक हो गया. एक बार लीक ओपन हो गया, फिनिश. Here we can ऑयल का फ्लो कम ज्यादा करके we can adjust the clamping force. Easy mode setup. Yes, टाइम बहुत छोटा लगता है इधर मोड सेटअप के लिए बिकॉज डायरेक्ट हाइड्रोलिक के more inward mode setup time. Here, stroke varies to mode height. Here, constant mode setup that we have seen. Clamp speed costly, controlled or stopped at any point. We can stop movable pattern here, but here we cannot stop. Difficult. एक बार लॉक हो गया बस लॉकिंग. by same speed. तो आवाज भी आता है. When the clamp mode close आवाज आएगा, mode open आवाज आएगा. Because the speed is constant here. Speed is not changing. Here now low maintenance as a part are self-lubricated. Here higher maintenance because pivot are there, links are there. Many times link can be break. Anything will happen there, train, and therefore maintenance cost for toggle system is high as compared to the hydraulic systems. Any doubt here? Any doubt in this case? Hello.
So sorry to ask this. You are mentioning here positive clamp and non-positive clamp. Can you repeat this?
Positive force, positive. Hello, positive, na?
Yes, sir. No, positive clamp.
Positive plan.
Yes, you are mentioning.
Positive. Positive means what, friend? There is a, that positive force is there. If you see here, let me tell you here in this case. यहाँ पे non positive clamps. Non positive clamp is what? Here you are supplying the oil. बराबर है. Hydraulic oil. यहाँ पे cylinder है. Yes, cylinder is there. And the ramp is there. This cylinder come forward due to the oil going inside here. Okay. And now the oil ka pressure, it varies. It is not a constant pressure. 120, 117, 119, like that. It is not constant. Remember this thing. And therefore, you are not providing here a constant pressure. 120, 120 chahiye, but 120 nahi milta. If you are not getting 120 here, you want 120 continuous till the injection finish, till the mode open. But no, here up to the injection to the closing to the mode open, the pressure varies. 119, 118, 120. But see in this case, here the pressure is continuous, constant here. No, 121, because mechanical links are there, mechanical links. And therefore, here also, a constant here. 120, 120. There is no variation at all. Because the pressure get exerted by the links, this link, mechanical links. Hello.
Yes, I understand. But what is the benefit of this?
Which one? Ye
Uh,
wala.
Here mentioning in toggle, you are mentioning that positive clamp, getting positive pressure. Exact.
Positive, yes, here. Here, because if you see the once the mechanical link open, right? It is not possible to again, that यहाँ पे it will never bend here. See now here, a complete lock is there, friend. Pivot lock.
Yes.
It is यहाँ पे it is not bending. It is not bending here. It completely once open. See now here, the mode is closed here. Mode is closed means, see now here, pressure here and pressure here is same. And therefore, the pressure is here completely 120 because it is a mechanical links.
One minute, sir. Actually, this arrangement of knuckle, once it is made straight, after that, we normally used to give the tonnage and set the tonnage. While setting the tonnage backside, there will be chain link. Along with that, hydraulic motor will be there. So whatever tonnage required once set, the tonnage will be the constant tonnage. Only the link will open and close. That is what actually in knuckle we normally set. So
No. That is see. Without that, we cannot operate. The backside, one wheel is there and chain is there, right? By that way, we can adjust the locking here, friend. In now, you see the big machines are there. There's a complete threaded wheel is there, and having a chain drive is there, right? By that way, you are adjusting the locking of this, right? But if you see here, a completely positive locking, there's no any vibration here in the locking system, friend. But here in this case, if you see, here oil कमती जाता होता है प्रेशर का. Oil का pressure is not constant here. आप देखो, the sound of this oil when you visit this direct hydraulic, आपको ऐसा एक particular sound आएगा. You will get a sound. There is a vibration in sound. But here pressure, if you see the pressure indicator here, it is a 120, 119 like that. Not constant pressure. And that's why it is called as a non-positive clamp. Non-positive. But here we can measure the pressure in this case. Now, we can see here, hydromechanical clamp. Hello?
Yes, sir. Yes.
This is a hydromechanical clamp now. See now here. See here, large cylinder for the clamp force. This is a large cylinder here.
Okay. Yeah.
This is for the clamp force. This clamp force. Okay. Now, small cylinder for the mode open and close. See here. This will help you. This mode open and close. Now see the mode is in close condition. Right. That's why, see now the piston is here. Like that. It's a cylinder.
Yes.
The oil push this, the piston forward. And that's why it comes forward direction. Okay. Then it is swing plate is there. Swing plate. When it is require ejection, you can eject the article immediately. Here is a ramp. This is a ramp. It will help you to that ejection of the articles. The mode close here. See now. Now see, this is the mode open. See now that time a small cylinder. See, it is coming here. See now here it is going this side. See now here it is coming back here. Okay. Now see here the cylinder. This piston also coming backward side now. Hello. Are you getting me, friend?
Yes, sir. Yes, sir.
It was simple, very simple. And people are using this friend nowadays in the market. Now we are going to see the a timerless machine, hydraulic control. What is the advancement in hydraulic control? Here. Now see here, this is a timerless machine. Timerless machine is there. There is no timer. See now, no timer is there. Now here, a C is a C frame. Is a C frame here. Please mute yourself. Hello. Please mute yourself. Hello. Yeah. Okay. See here. Yeah. Please. Mute yourself. Hello. Hello. Am I audible, please? Yeah, somebody talking in between. Somebody talking in between. Yeah, okay. Now, friend, we are going to a different type of machine now. A timerless machine. It's a timerless machine, friend. This is also exhibited in the many exhibition. Now, what is the advantage of this? See here, no timer. Only the hydraulic cylinder, a piston. Now see a rotary joint here. Rotary joint. It's a, that it rotary type. Now here see the movable pattern. See now mode is here. Mode.
Sir, it is for big type of product or small type of product, sir?
No. It's a big type of yes, very big, huge type of.
Okay.
And hey, see the is that in a C type frame is there?
Bumper, it will be there.
Yes. Correct. The bigger one.
Okay, sir.
And it have a lot of advantage, friend. I will show the advantage of this also. See, this is called a timerless machine, right? See here, the molds are here, get attached here. This is the rotary plate is here, this cylinder here. Now, what is happening here? The main advantage of the system, there's no limitation of the mold pattern size, correct? You can, any height, any type of mold, you can adjust here.
One doubt, in this injection unit will be on the fixed platen side only, no, sir? In
Which
all
one?
of injection unit, that will be on the fixed platen side only, no?
Correct. Yes.
There is no right?
Correct. You are right.
Okay, sir.
There is no timer, so the mode dimensions is not so important. Also, mounting of the mode is easy and it is a very useful when the product eject from the mode is manual. What are the advantages? See now, much larger mode mounting possible. Large stroke compared to the toggle type machine, yes. Full machine capacity can be utilized. Smaller machine can mold larger component, big component. Saves floor space. ज़्यादा space नहीं लगता है. Saves electrical energy because of the reduction in the size of the machine. Has the capacity to reduce the weight of the molded component because timer stretching is not there. Machine become very flexible for future modification. Now, easy access to mold cavities because of the absence of the timer. Now, robotic possible. Robotic arm movement become easy. Very easy. Fewer moving part, so lesser wear and tear. So longer life for the machine. Lower lubrication required. Removal of mold plates much simple and greater stability. there are a lot of advantages, and nowadays this
One
machine
doubt.
is.
Yesterday, you showed one video of part is getting removed and assembled within 1 second, 1.5 second, I think. That is possible only in toggle or even in hydraulic it is possible.
It is in a hydraulic possible. It is possible.
Because response time, power pack condition, everything plays a role in hydraulic. That's
Correct. It is possible here also, friend.
same 1.5
Because
is possible.
nowadays the modification is possible here. See now, machine become very flexible for future modification. You can use in a microprocessor also. Everything you can address here, friend.
Understood, sir. Okay.
Yeah, I will show you some video here, friend. Hello.
Yes, sir.
Any question on this thread?
No, sir.
We will go ahead now. Now, electrical induction molding machine. We have seen manual, toggle, direct hydraulic, hydromechanical, and also we have seen the timerless machine. Now we are going to the next version is electrical machine. Only the by electrical, signal, you can operate the machine. That is called as the electrical machine. Now, see, 1 minute. See, in the past, there have been attempt to make injection molding machine without hydraulics. Developing servo motors during late 70 open up the opportunity for very energy efficient of the electrical injection molding machine. Cincinnati this is a very good company. They started this manufacturing. Then Pune, Nisi, Battenfield, and others have developed the machine without hydraulics. They have started that time only. Since demand for power during a molding cycle is not constant, but it is a variable. Therefore, the power is wasted during low demand power period. Moreover, there is a efficiency factor of the 80-90% between the electrical motor and the hydraulic force. In all electrical machine, each hydraulic actuator, that is a cylinder hydro motor, is replaced by the power train consists of a AC servo motor of a suitable power rating with, see, AC servo motor we are using here instead of the hydro motor with its control for speed, ball screw, and two pulleys with one belt. Feedback is provided by the high resolution position. Feedback devices like an optical encoder. There is no common prime mover. It means toggle is operated by the servo motor. Screw is rotated by a separate servo motor. Ejector is operated by a separate servo motor. Injection and suckback by separate servo motor. Injection unit movement by the different servo motor. Right. Therefore, see, friend, how they are using the various type of servo motor to operate the machine. Whenever the actuator are not in a operation, the servo motor remains on. See, this is the energy saving, and therefore it consumes just enough power that is required for the operation. Here, because of the electrical machine, the control is precious. Close tolerance of the parts, it is also exhibit remarkable, repeatable. See, friend, once you adjust the machine, there is no fault in the process. And every machine is get operated by the servo motors, different type of servo motors. Efficiency factor, if you see the comparing 80 to 90%, okay, as compared to the hydraulic machine. Now, see, it is a found. 1 minute. See, it is a pound to 25 to 62 power consumption when compared to the equivalent hydraulic machine. Because it is I told you, one operation is going on, that time other is stopped. Therefore, you can save 25 to 60% power in absence of one. In absence of oil, water requirement is reduced by the 70%. The machine length is also reduced, giving a 15% saving in floor space. Cleanliness around the machine is ensured in absence of oil, no oil, therefore no spoiling. Therefore, a complete 70% is efficiency because of the no oil. Cleanliness around the machine is ensured by the absence of oil. Silent working environment, no sound. See the sound here, lower than 70 dB. See the other machine, 120, 200, 300, like that dB noise. No sound at all here, friend. Then, what kind of accuracy is expected from the all electrical machines? See, now these are the company manufacturing the uh, electrical machine. This is a comparison between this short size here, Electra and hydraulics. These are the comparison here. See the tolerance here, friend. Comparison of the accuracy between the all electrical and hydraulic machines. Ejector forward, see now here, 0.050 mm. Here is 0.100 mm. See the इतना minimum हम कर सकते हैं. Clamp open position. Here is a 0.050 mm. Here is a 0.075 mm. Cycle time 6 seconds. Here is a 10 seconds. See, this is a difference. You can measure power consumption low, high production, right? And sophisticated, lower space required for the machine. All these are the advantages of an electrical machine over the other machine. And if you see the accuracy and the repeatability, it is excellent. It is a more energy efficient than any hydraulic machine. Therefore, the demand for these machines expected to rise in next 10 years. All electrical machines will dominate the market in advanced countries. Nowadays, they started now. If you see the India also, people are buying electrical machines because of the power is a very costly in India now. And that's why they, for saving purpose, you can use electrical machine. It is a very sophisticated machine, large production, accuracy is also you have seen here, the comparison chart, and you will get a more accuracy. Now, friend, we will go to the vertical injection molding machine. Vertical. You can buy this machine, maybe 2 lakh, 2.5 lakh, such a machine you can buy. And you can, manufacture, see, such a type of small atoms you can manufacture. Right. देखो यहाँ पे metal add कर दिया है. Right. Metal. This is plug. This is also plug. This is also plug. Such a type of plug you can manufacture by using the vertical type of injection molding machine. See, this is a panel here. There is a actuating unit. Then hopper, the tie bar, 1, 2, 3, 4 tie bars. These are the hydraulic lines are there. There is a mold. It's a fixed platter, movable platter. It's a cylinder, not cylinder, barrel. And inside the barrel, there is a piston or maybe screw. Now, friend, if you see, this is a movable platter attached to this a core plate. This is again cavity plate. This is a complete panel. We can up and down. All the function can be done by this. Even manual, semi-manual possible in this case. See here, screw diameter 32 mm. So the specification given of the vertical machine, injection pressure 1260 1677 kg per centimeter square possible. Injections capacity 58 to 74 tonnage, 55 to 74 tonnage, or maybe centimeter cube. Injection weight here 63 to 85 gram possible. Then here injection rate 42 to 57 cc per second. Screw speed maximum maybe 150 rpm. Screw stroke 120 mm. Nozzle stroke 150 mm. Nozzle contact force 2.4. Then clamping unit. Clamping force 25. Then clamping stroke 215. Maximum mode space 335 mm. Minimum mode height 145 mm. Overall size of the platen, see here. इतना बड़ा platen होता है. Length and height. Space between columns 400 and 150. Hydraulic ejector force 0.7. Ejector stroke 20. See, this is a vertical machine frame, and people are in specification given here. Just the idea should get an idea what we require. A 100 gram ka article you can manufacture by using this type of machine also generally, and people are using this because you want to some electrical encapsulation, some type of article you have to manufacture, some insert you have to manufacture. It is possible by using this vertical type of initial molding machine. Now, friend, we will go to next slide. Can we take the break of for 2 minutes, friend? Hello, hello, hello.
Yes, sir.
Yeah,
Yes, sir.
we'll take a 2 minute break, friend. friend, here some process parameters I am going to show you, and how these parameters are get, vary as per the material basic structure. See the acrylic polymer, it is having a high impact acrylic polymers, then cellulose plastics and the nylon. See the maximum thickness of the article is less than 3 mm. Here is a middle one, and it is a over 6.30. Article thickness is higher in this case. And see the cellulose also, the same the dimension they have used here. The article thickness is 3.175, 3.175, 3.175. See the higher 6.35, 6.35, 6.35. Now see how you keep the temperature here, friend. Zone 1, feed zone, second, middle zone, zone third, a metering zone. And then last is the nozzle zone. Then melt zone, mold temperature. See the mold temperature here, mold temperature. I told you, people, some processor using the same mold temperature, maybe 20 degree, that we are using for the polyethylene polypropylene. See, therefore, this is the the operator should know the mold temperature. Injection time, see now here, material to material varies. And if you see, the total pressure here, in kg per centimeter square, they are given here also, and see the pressure. Friend, you can see the zone 1 feed temperature for a lower thickness article, 225 to 260, over size 205 to 260. Same thing here, 238, 222. Therefore, the temperature is higher here, lower in this case here. If you see the thickness increases, the temperature goes on decreases. Setting temperature. See, all zone, nozzle zone, melt zone, mold temperature. See the mold temperature here. That also goes on, decreases here. Injection time, see here, it requires higher temperature injection time. Here is a very low. Total cycle time in second, here is high. If you see here, 1 minute and more. Here is a only 45 seconds. Because of the thickness is less than 3. See now, see the cellulose plastics. See the, for 3 mm, see the temperature here, 171 temperature. See in this case, the temperature is same, just minor difference is there, but it is goes on again decreasing. The cycle time also here increases because of the thickness is very high of the article. See nylon 6, less than 3 mm, see the temperature here. Zone 1, zone 2, zone 3, nozzle, melt temperature. And see here, at a thickness having a more than 6 mm. Again, it goes on, somewhat decreases as compared to the first one. Now, see here, the cycle time also goes on, increases. So the pressure required here, 1757. See here, 1406. See here, 140. Therefore, it have a lower pressure, and it is have a higher pressure because nylon 6 you have to add more force here, more pressure here, injection pressure. See the second, polypropylene, polystyrene, and styrene acrylonitrile. Here also, they have compared with the 3 mm thickness, 6 mm thickness, 3 mm, 6 mm thickness. And in between that, in between of the article, see the zone 1 temperature here for polypropylene, 235. Can anybody tell me the melting point of polypropylene? Hello? At what temperature polypropylene melt? Hello? Am I audible to you, friend? Hello?
185 to 90.
हाँ, कितना पीपी का कितना melting point?
185.
Yeah, it is a 160 to 180. It is a very, but it start to melt at 160 only.
Okay, sir.
But see here, the melting temperature कितना है? Zone 1 का, feed zone का, very high. See here also, thickness increases, it is goes on decreasing. Cycle time goes on increasing because it is the mode should be filled completely. Ejection time will be high in this case. See, a general purpose polystyrene. Cycle time is, see, 40 to 160. The pressure required in moderate here because this is a easily flow material, polystyrene. It requires higher pressure, PP. See now here, in this case, styrene acrylonitrile, it also flow very fast because the hard phase. Due to that, both are hard phase. It made very fast and move flow very fast, this material. Therefore, it requires less pressure as compared to the PP. Now, see, this is also a processing chart, a parameter chart for you, friend. Here, the material ABS, acetals, dendrine, acrylic, and here some alicyclic resins are there, and monomers are there. The cellulose plastic are there. See the injection molding temperature.
Sir, actually in this we are not talking about metal residence time, no sir. That is also important, no sir. But it can be accepted. Otherwise, it will get degraded.
See, residence time is very important, friend, because some material are very sensitive material. For example, PVC, polycarbonate, and PET. These three material immediately start to degrade. If the residence time will increase, it should be come out very fast from the barrel. Yes.
Actually, some six shots can be there inside barrel. General, there is a terminology in our industry, but is it 6 shots or is it based on some other? Because barrel size is also plays a role. 32 dia barrel or 36 dia barrel or 25 dia barrel.
Yeah, the barrel size is also very important, but not only barrel, whole assembly, screw and barrel assembly. That will also play a very important role because how the flights are arranged, what type of screw you are using, it is single stage, double stage. I'm coming to your answer. Don't worry. I have that. I'm going to take this today or tomorrow. Screw, design of screw. It will explain you everything.
Okay, sir.
Okay, don't worry. Then extrusion grades, because not only injection molding, also we are also going to discuss the screw for the extrusion also. how it differs. We will take everything. Yes, you will get everything.
Okay, okay,
Yeah,
sir.
yeah. See now here, ABS, you know that it is a very high impact resistance polymer. See the temperature injection body temperature is 180 to 275. See the injection body pressure, it is also very high here in this case friend. Mode linear shrinkage. See the shrinkage for ABS. It is still there, shrinkage. People are also finding out the some new design to reduce the shrinkage. These are the even you are also filling this ABS with the glass. That time slightly temperature you have to increase that time. You should not use the the same temperature, because of the you are filling the glass inside the ABS 20 to 40%, and also the pressure will also very high because of you are adding here a glass in the ABS. Therefore, the pressure increases. If you see the deadrin now, deadrin, there are two type of deadrin. Yesterday I told you, homopolymer and the copolymer. Now homopolymer deadrin, if you see the temperature 180 to 235, copolymer slightly 5 degree increases. If you add a glass 20% in deadrin, see the temperature of barrel 176 to 240, you have to adjust there. Then if the glass filled maybe 25% and more, then see the again temperature you have to increase slightly. Then fiber reinforced. If you add the fiber, then again you have to reduce some temperature at a higher level, but the initial temperature slightly you have to increase. See the pressure is a constant here in this case for all, because gelatin is a material. You can easily, that once it is a melt, but I told you it's difficult to flow, friend. Again, see the shrinkage here, higher shrinkage. Why this shrinkage is higher? If you see the here shrinkage lower, but see the here shrinkage higher. Because why shrinkage higher? Because it is a crystalline polymer, and due to that, the if you want a 3 mm diameter, you should see here that shrinkage of this, right, deadrin, and you have to design the mold that way. Now acrylic. See the acrylic here, temperature 160 to 80 degrees Celsius. Then if you add some impact modifier there, again you have to increase the temperature for this. Then methyl methacrylate copolymer if you use, then 170 to 276 temperature you have to increase for that. Then acrylic with the multipolymers 200 and 240. See the pressure here increasing only by addition of the MMA. Shrinkage in this case is lower. Now allied resin and monomers, diarrhea, phthalate, DAP, friend, they have given some chart here, and cellulose ester, cellulose butyrate, cellulose nitrate, and how they are, at what temperature they melt. But these are the natural based polymers. So the pressure required very high for this.
Cellulose is for injection molding or?
Yes. Cellulosic sheet. We can extrusion sheet. We can make the sheet of the cellulose, friend.
What applications are cellulose?
Hello. Cellulose acetate, cellulose butyrate.
It's like a rubber sheet, sir.
No. It is a, it is a, if you see the cellulose acetate, it is just like a, semi-translucent polymer.
Okay.
Cellulose acetate.
The acrylic sheet, we are telling it is a cellulose sheet, huh?
No, acrylic is a different polymer. Acrylic is a polymethyl methacrylate. It's a different. It is a synthetic polymer.
Any applications are on this cellulose?
Cellulose, there are, cellulose, there are, cellulose acetate, cellulose butyrate, all the comb, if you see the comb, which are using to, अपना बाल को ये करने के लिए comb, that comb, चूड़ा type of comb,
yes,
from,
yes.
using from the cellulose material.
Okay.
Cellulose acetate. There are some parts which are also made up from the cellulose components.
Why not PP?
Yes.
That comb material, why not PP? You told us that we are using comb material for cellulose. Any specific reason using cellulose?
No, there are 3 grades of cellulose, friend. Cellulose acetate, cellulose butyrate, cellulose nitrate. If you see the cellulose nitrate derivative, there are 3 derivative. हम लोग सेलुलोज का 3 टाइप का पॉलीमर बनाते हैं मार्केट के अंदर. मैन्युफैक्चरिंग सेलुलोज इन 3 grade. Cellulose acetate, that is used for number of applications, spectacles, the frame of the spectacles. Hello. The frame of the spectacles, it is made from the cellulose only, cellulose acetate.
Yes, sir. Yes, sir.
Then cellulose butyrate. This cellulose nitrate. If you see the cellulose nitrate, or maybe nitrocellulose. If you see the ball, tennis ball. Have you seen tennis ball?
Yes, sir. Yes, sir.
Tennis ball को jump करो, ऐसा एक throw करो, what will happen?
Yeah,
It
will jump.
It will bounce.
The bounce property will be more.
Yes, resilience. That is the resilience. बोलते हैं उसको.
Resilience.
Yes, it will bounce like anything, friend. And this is the only material, friend. Very explosive things, nitrocellulose. Right. If you burn that polymer.
So you are telling we are using cellulose for comb because due to bouncing property. PP also can be. So we are not using PP, can also be used for that comb.
No. There is no any material which will give the property of a nitrocellulose, friend. Nitrocellulose ball, the tennis ball from the nitrocellulose. Now, if you that just put on the flame, immediately it will start to burn, and it will burn very fast. आप कुछ water bomb लेके आओ, nothing will happen. वो जलता ही रहेगा. You cannot control the that nitrocellulose fire. The fire will that they will not do anything for that. The nitrocellulose pura that it is a very material not self-extinguish. It will burn very fast. If you see, you just do the experiment, nitrocellulose, but घर के बाहर करो. That fire will be, it will very जोर से आग पकड़ता है वो nitrocellulose. Now, friend, such a materials are there. If you see again, polyethylene, ethylene copolymer, right? This is also.
Sorry to interrupt you. In between, you mentioned that ABS plus GF, right? I generally experience. Generally, we are using PP plus GF, but I never seen that ABS plus GF. So, due to which property to get we are adding GF in ABS?
ABS, if you see, dimensional stability property can be enhanced by adding the fibers, glass fibers in the ABS, friend. And this is the only property we require.
Dimensional stability in terms of shrinkage, right?
Yes. If you see, even the parts which are using an aeroplane, right, or maybe automobile, we are adding the glass fiber. They are 20 to 40% in ABS.
I think we are adding the GF, glass field. We are adding for strength purpose.
Correct.
But you are telling that dimensional stability.
No. See, dimensional stability increase. How it increase? By only strength. Therefore, it increase. Yes.
That's what I asked.
It increase the tensile strength. Hello. It increase the tensile strength.
That's what. Okay. But
And
I never
if the,
seen a ABS for
if,
that
if
adding
the
GF.
if the
Uh,
strength increases, the dimensional stability will increase.
maybe ABS material is costlier. That's why people are preferring PP plus GF. That
No,
might
no,
be the reason.
no, it is not like that. Some people want for some application. We want that to there are some application, friend. It is
Okay, okay.
yeah, yeah.
If it is the strength requirement, then
Correct,
PP plus GF compared to ABS, it will be cheaper now. Or
correct. No, see, glass is again fiber, right? If you add the fiber, you will get the reinforcement in the structure. जैसे हम लोग सीमेंट के अंदर सली डालते हैं, सली मेटल.
right. Same
हाँ,
like epoxy,
same,
all these
same.
glass fiber we are adding for this same
Correct,
thing.
correct,
So
correct.
that is very clear, yeah. But I
Yes,
never seen that ABS plus GF. That's
yes.
my
People,
doubt.
no. People are adding very, that minor level. It is they are adding in the ABS also. Now, friend, all these, even many fillers they are also adding in the ABS friend. Carbon fiber, carbon fillers, they're also adding. Why? We are using the fillers in the any plastics to reduce the cost. Majority. Filler. I'm talking about the filler, not fiber. Filler. Right. हम लोग फिलर क्यों ऐड करते हैं? तो टू रिड्यूस द कॉस्ट ऑफ द पॉलीमर. फिलर हैविंग a 20 rupees kg, 30 rupees kg. Polymer is about 200 rupees per kg. And we can add filler 30%, 40% as per your application. ज्यादा स्ट्रेंथ चाहिए, क्या चाहिए, राइट? एज पर योर एप्लीकेशन यू कैन ऐड. जर पर कंपाउंडर, आप कंपाउंडर भी बनो प्लास्टिक का. You know that there is a major benefit. Hence, friend, if you see the filler not only reduce the cost of that compound, but it also give the dimensional stability. It also, that by adding the filler, the strength will increase. Strength, right? Easily, suppose even by adding the filler, many things are there, friend. Shrinkage, you can reduce the shrinkage by adding the filler in the material. There are 3 to 4 benefits by adding the filler in the plastics: to reduce the cost, to give the strength, to reduce the shrinkage, to reduce the warpage. That's why we are using the filler in the plastics. Now, there are, see here also, they have given some copolymers, then polyphenol, PPS, sulfide, unfilled. See the unfilled having the temperature and filled having the temperature. See the here, injection molding pressure somewhat higher in this case. If we add the asbestos and the glass filled pipe, this PPS, polyphenol sulfide, then polypropylene. Generally, we are adding the talc, inner field, right? See the temperature that time 180, but see the other time is 200. Even we can add the glass fiber in the polypropylene. We can add rubber in the polypropylene, right? For example, EPDM, ethylene propylene diene monomer. We can add a rubber in the polypropylene. That is called as a EPDM. Now, friend, if you see here, the temperature, injection pressure, and the mode shrinkage. Here, see the shrinkage. If we add the, if you see here, we are adding the fillers. Everything they are showing here less shrinkage because we are added a filler as compared to the virgin material, the polystyrene. General purpose polystyrene, impact polystyrene, right? See their molding temperature, injection pressure, and shrinkage. See, these are the always glass filled fibers, fillers. They are always help to reduce the shrinkage. They also help to increase the dimensional stability, right? This you have to keep in mind. Again, if you see the these vinyl polymers. For example, PVC, rigid PVC, flexible PVC, right? See the temperature here, the less temperature, right? 182 to 190, not more than that for PVC. And see the shrinkage here, 0.01 to 0.8. Rigid PVC having the lowest shrinkage as compared to the other polymer, friend. Rigid PVC having a lowest shrinkage. Then, यहाँ पे flexible feed, then vinyl formal molding is also there in the market. PVC is also compounded PVC. See, PVC is a material, friend. We can add in a PVC any type of material. Listen me carefully. PVC is a versatile polymer. PVC is a versatile polymer. You can add in PVC maybe the powder of the wood. You can add a very fine powder of the, clay. Anything you can add. You can add the glass powder. You can add the cement powder. You can add anything in PVC. It will take. Nothing will happen. Compatible. PVC with compatible with any things. Even if you add the stone powder, it will also take PVC. And that's why I'm here telling you the PVC is a versatile material. Why versatile? Because it can take anything. But it is the hand of the compounder. How we add the percentage of all these ingredients in the PVC, virgin PVC. Then if you see the thermostat also, melamine formaldehyde molding powder, then phenol formaldehyde molding powder, then butadiene acrylic copolymer. These are also, there are a number of, by adding some fillers, asbestos filler, mica filler, glass filler, no fillers. See the temperature, the effect of temperature here, they have given here. How you can use the temperature here, molding temperature. How the pressure is increased here by adding the filler fibers. And what is the effect of by adding all these things on shrinkage? Yes, there's a definitely shrinkage is going on decreasing as per the adding of the filler and fibers. Then this is also, if you see some polymer epoxy resin, the fluoroplastics. If you see the fluoroplastics, Teflon is the fluoroplastics. Then epoxy resin, glass feed, mineral feed. See here, the shrinkage is very less in case of the epoxy resin also, friend. Then fluoroplastics, polytetrafluoroethylene. See the here, highest pressure. It's difficult to flow. Very high flow. And see the shrinkage, very high shrinkage. Friend, see the Teflon shrinkage is a very high shrinkage. While designing the mold for Teflon, you have to, there may be 12%, friend, 12% shrinkage is there available, showing Teflon. Then how can you design the mold? Then 12 mm, you have to put the excess mold. Suppose you want a 100 mm size, 100 mm size, then you have to design the mold 112 mm because to compensate the shrinkage of the Teflon. See the highest shrinkage polymer, कौन सा polymer है? Teflon. I told you 12%. My friend, see the nylon also, it have also having a higher shrinkage because they are the crystalline polymers. Nylon 4 and 6, nylon 6, then nylon 6 and 12, nylon 6 and 10, nylon 11, nylon 12. These are a nylon here. And see the shrinkage is higher or in all cases. 1 point something, 1 point something. Friend, this is about the effect of a filler fiber, different type of filler, different type of fibers with the virgin plastics. They have given here the data for the molding temperature, molding pressure, shrinkage, and specific gravity also. Right? We have seen this slide. Yes, we have also seen this slide. What is the need of drying of plastics? Friend, if you see, there are some polymers. They absorb water or moisture from the atmosphere. But there are some polymer, they, I can say you that they drink the water. They drink the water. Which are that polymer? Nylon. If you put in the water, it will try to drink the water, friend. Same ABS, polythermamide, polysulfones, polycarbonate. They absorb moisture from the atmosphere. And this is known as the hygroscopic nature. The moisture in a plastic material result in the poor surface and loss of physical properties. Yes, if the moisture present in the polymer, then definitely your all property, the shining will goes down. Physical property goes down. And there will be number of problems in the processing. You will not get a quality article. Therefore, we have to pre-dry the polymers before putting in the hopper. Why? Because if you get the poor surface, what are the problem with the surface? Bubbles, silver marks, spillage. Why this happen? Again, the loss of physical property. Your tensile strength goes on decreasing, impact strength goes on decreasing, and poor melt flow. Due to poor melt flow, bubbles will be there. And therefore, we are drying the polymers. Now then, if you see the relative humidity and the dew point, atmospheric air is a mixture of the various gases, water, vapors. This water vapors in the air is known as humidity. The amount of water that can be contained in a kg of air depends upon the temperature and the pressure. At constant pressure, warmer the air, the more water vapors it can retain, correct? When air has absorbed the maximum possible water vapors it can retain, then the air is said to be saturated. And therefore, the relative humidity is the actual water content in the percentage of that of saturated volume. Therefore, friend, if you compare between the two readings, if you see, the measurement of relative humidity is done by reading the dry bulb and wet bulb temperature. Wet bulb temperature is used is a read when the wet wick is covered over the bulb deep in a distilled water container. The comparison between the two readings give you the measurement of water vapors in the air. Therefore, friend, we can find out the how much vapor is present in the air. The lesser the difference, the water, the weighty the air. The greater the difference, the drier the air. So this is always we are using in the which are the drying equipments. See, friend, pre-drying is essential. I told you. Some polyethylene, polypropylene, you can simply put in the oven. But the material like ABS, nylon, polycarbonate, this require a dehumidifier. Dehumidifier. Keep in mind, dehumidifier is required there. And in some cases, suppose polypropylene, polyethylene, the hot air dryer, it can be worked there. Nothing will happen. Now, see there are 4 compartments of dehumidifier. Each compartment have a function to absorb the the moisture from the material, because without this we cannot process the nylon, dedrine, polycarbonate. These are the material. ABS material absorb the water. Therefore, by using a dehumidifier for this material, before adding in the hopper of the machine, they absorb all the moisture from the ABS nylon. Therefore, this is a dehumidifier here, friend. 4 compartment. The material goes through each compartment. Each compartment have a function there to remove the water from the granules, plastic granules. And you will get a dry material from this dehumidifier. See here, in a hot air dryer, what is happening?
Sir,
There is
what about, sir, other than the hotter dryer and desiccant type dehumidifier, is there any other dehumidifier, sir?
No, hot air dryer generally used for to remove the surface wetting. Surface में जो moisture होता है ना,
हाँ सर,
उसके लिए hot air dryer do work for polyethylene, polypropylene, yes, but you cannot use hot air dryer for nylon, for ABS. उसके लिए you have to use only dehumidifier, because it will complete 100%. It will remove the water from the ABS and nylon.
Okay, but for polypropylene, we are not heating, sir. Preheater
No.
not used.
See,
only
what is happening generally in the humidity, that area where the humidity is very high, that there you have to use oven, and even this hot air will work there. Hot air dryer. यहाँ से hot air छोड़ते हैं हम लोग. यहाँ पे material होता है. It will go through that. It will remove all moisture. And again, you have to pass this into the dehumidifier. Not dehumidifier, popper of the machine. Direct. Not need to use the dehumidifier for the material. They are hydrophobic nature. Hydrophobic. They are not loving with the water. Hydrophilic means loving with the water. Hydro means water. Philic means loving. Philic means loving. Hydrophilic. Water loving. Which are the water loving polymer? Nylon, ABS, polycarbonate. Which are the hydrophobic polymer? Hydrophobic. Polypropylene, SDP. These are the hydrophobic. They will, never, absorb the water inside.
Okay, sir.
But surface water is there. Moisture थोड़ा तो होता है. Because of their atmosphere, they absorb. Not absorb. They never absorb. But वहाँ पे जाता है moisture. But to remove that moisture, we have one system. Hot air dryer. Finish. It's very good. Now, friend, the handling raw material, some operations are there. Some, nowadays the robo is there. If you see in Europe countries, the loading system is the automation take place there, material handling machines. Even more than 30 tons of the single material is consumed per month. Material conveyed through the vacuum or pressure method from bulk storage silos through a blending station to the machine. All automation is there. Many times, basic materials is supplied to the machine through vacuum lines and dosing lines. Blending of color is done individually machine. Similarly, dehumidification, preheating of the material is also done at the machine itself. There are nowadays there are new machines which are handling the material nicely in an automatic plant. See in India, now this is about the Europe, but in India, see we have seen the installation dehumidifier. We also seen the hot air dryer are there, and the automatic vacuum loader is increasing use in many molding shops. It avoids the spillage and prevents the contamination of the material. Nowadays, we are using these two type of, uh, machines, a hot air dryer and a dehumidifier. In many, companies, they have that. But why we are preheating the material frame? Because it is a moisture. Then second thing, if you not remove that, then there will be problem in the article. there may be shrinkage, maybe some surface problems. There may be some voids present in the article. To remove, and even by heating, your cycle time is decreased. By preheating, your cycle time is decreased. Therefore, there is always benefit. But you have to do this operation immediately. Friend, what are the other supporting equipment required in injection molding shop? Raw material handling equipments, upper loader that you have seen, dosing, blending unit, humidifier, hot air dryer, granulator, more temperature control. Nowadays, it is all plant is having this machine, robo conveyors, part separators. Service lines are cooling water supplying line, chilled water supplying line, right? Supply of the compressor here is required. Friend, all these supporting equipments or auxiliary equipments present in the induction molding shop. Now, we will start the screw, friend, and we will go detail in the screw now. The screw will help you, it will tell you many things. See, there are different part of the screw. This is the tip of the screw. See the screw ka tips. A different type of, see the slots are there. See, this is also slot here. And these are the, sir, see here, a multiple, ears we can add there. See, here also we can add. There is a slot to add this. If you want a turbulent flow, if you want a linear flow, you can easily add this type of element in the screw. Now, friend, see this is a screw is there. We have seen this is the tip of the screw. There are threads of the screw. It is called as a root diameter. There are number of flights are there. Shank and hub is there. This is a hub. This is shank. Now, friend, what is the main role of screw is? Converting a solid granules into the homogeneous melt is known as a plasticizing. The main role of a screw. Convert granule into homogeneous melt. It have 3 zones we have seen. Plastic material under shear. Yes. Shearing action take place here. Heat is built up here due to the shearing action. And therefore viscosity goes on decreasing. Remember this thing. This is a very important part. Therefore, it will thinning the material. Thinning पतला पतला होता है, like water जैसा, due to the shearing action of screw. At the tip of the screw, non-return wall is fitted यहाँ पे, that we have seen. Therefore, the main function of screw is plasticating. Now, friend, we will talk about the screw and thermosetting processing tomorrow. Plus, we will add some type of faults in the injection molding process. वार्पेज कैसा होता है, सिग्मार कैसा होता है, क्यों आता है, why they are, in the article. We will take all the things tomorrow or maybe on Monday, right? Therefore, we will cover many portion, friend. Don't worry. Even we are also covering thermosetting molding. How the thermosetting, whatever changes you want to do. See, generally injection molding also done by the thermosetting plastics by injection molding. It is possible. And what are the small changes in the machine that we can see tomorrow? Plus, we can talk about the screw, because if you know about the screw, then you can apply your mind in the processing. Friend, we can stop here today.
Sir, one more doubt, sir. Actually, I thought of in between itself, but okay, last I will ask. Thought of. Sir, actually, if we buy a bucket, some company says that this is high quality, and when we press also, it is flexible slightly, and the cost is very high. Another bucket, if we see, it is very thin, or some color or some difference will be there, or it will have a problem. Like only life will be very less. Like that, there are many articles, sir. Do we have any list that these are the articles can be produced in this particular material, and this should not be used, or this is the inferior quality? Like that, is there any table, sir?
No, it is not like that. What is happening? Many times, the material, raw material we are using, that not proper virgin material, virgin, pure
Yes, sir.
polymer नहीं होता है वो. That is a recycled material. If you bring the China toys, it is a complete recycle. वो लोगों ने उसको 10 बार यूज किया है वो प्लास्टिक को. लास्ट में उसमें सब कलर मार के सब ब्यूटीफुल बना के भेजा है हमारे पास. ऐसा भी many things are there, friend. That material don't have a strength because of there are above 50% scrap is there. Many things we will talk about at the time of.
If that is the case, while granular or testing sample, we can check it now. We'll not use that kind of a sample.
Yes, we have to check that. That's why I'm telling you. If you check that, then such a type of the faulty material and the raw material, we should not buy from them. Even there, the article also, we have to check up that, and they are just dumping in the other countries, and people are buying that. If you see the global market, they are just that giving them with a lower price because they have to sell that. They are earning the dollar in that.
Yes, sir. Yes, sir.
Yeah.
But thing is, if we have some idea, no, like plastic bucket means it will be mostly polypropylene material. But if it is breaking, or if it is very not flexible, maybe it is of this material. Like that, we can understand, differentiate while we purchase. That is why I thought.
No, see what happened. The molding is a technique, right? If if you give machine, two machines, same machine, for the two operator, to the two operator are there. One is a plastic engineer, other is a not plastic engineer. He don't know anything.
Yes, sir.
Now see what is happening. Bucket कितना साल जाना चाहिए? Bucket should be go for 10 year or 5 year or 2 year, or it should break within a 1 week. That is in the hand of processor, operator. How you change the parameter on the machine, that is a very important, friend. Many
But-
times what happen, people are, they are not using the proper mold temperature. See, these are the main things. Water mold के अंदर छोड़ना है, उसका temperature कितना होना चाहिए? That is very important. See, I told you, I have shown you here slide also. कि mold का temperature इतना रखना है for this material.
Yes, sir. Yes, sir. Okay.
That is not follow in India. अपने पास एक टॉवर होता है, कूलिंग टॉवर बाहर, कंपनी के बाहर, वो कूलिंग टॉवर ठंडा करता है वाटर 17 डिग्री और 15 डिग्री, वो सेम वाटर आता है मोड के अंदर.
But mostly chillers, nobody using, sir. We are using only coolers.
मैं वही बोल रहा हूँ आपको, फ्रेंड. we don't follow the rules. Right. We are, secondly, आपने को दिखाना है बॉस को, अरे देखो, within 8 hours I have made 1,000 sample, 1,000 product. मैंने, I am the good engineer. But after 8 days or 1 month, that start to be, breaking because of the shrinkage, sink mark in the article, many things. Again, that comes 1,000 piece again coming into the industry. Again, you have to cut and grind. Again, you have to use that, 20% in the virgin material. This is going on, friend. I am telling you. Therefore, don't use the machine. You see, the person, operator should know something knowledge. So cooling time affect everything, friend. आप उसको cooling time maximum नहीं देंगे, what will happen? You are arresting the polymer within a very short period of time by putting the chilled water inside. अरे cooling time कम करो, production बढ़ेगा. बस गया, उधर ही गया पूरा. Because there is a lot of shrinkage in the article. Bucket क्यों छूटता है? Shrinkage. Means shrinkage, fault is there, friend. You are arresting that chains very fast. उसको time नहीं देता है relaxation के लिए. Use some time to relaxation of the chain in the mold.
Okay, sir. Okay.
See, shrinkage.
Sir, also,
And therefore,
I am here for Mr. Kalnan.
And the chain after 8 days, they will try to come its original position. वो after देखो सब मोल्डिंग होने के बाद वो चेन क्या करता है, प्लास्टिक चेन है वो मेमोरी, उनको मेमोरी होता है, वो बराबर वो आपस में दूर जाता है, दूर जाएगा तो उधर व्हाइट मार्क आएगा तो उधर वो क्रैक हो जाएगा आर्टिकल.
Sir, then tomorrow if you can show some table of what is the temperature, mold temperature and throat temperature required for each of the material, 13 material you have shown. For each of the 13 material, how that, if you can tell, it will be helpful, sir. Because
I will try to my best level. I will
yes,
just
sir.
check up.
Delrin and HTTP material we are giving to one supplier. He is not giving a chiller at all. Second
thing, I told you, the parameter you have to complete control, and the shrinkage is the main, the things that will, and that's why we are taking the Tipol test. Tipol test. टिपॉल एक सोप बेस्ड 12% सोप होता है, उसके अंदर वो हम लोग डालते हैं 12% इन द वाटर में डालते हैं इन द टेम्परेचर इज 80 डिग्री सेल्सियस. वो बकेट उसमें डालो 8 आवर्स. टिपॉल सॉल्यूशन में टेम्परेचर रखो 80 डिग्री सेल्सियस उसका, वो वाटर का. उसमें सोप डालो 12% टिपॉल सॉल्यूशन. एंड see after 8 hours that bucket, suppose किधर white mark आया ना, तो बोलने का ये श्रिंकेज है. वहां पे वो बकेट ब्रेक हो जाएगी 4 दिन के अंदर,
जल्दी ब्रेक हो जाएगा.
yes.
Not withstand the load.
Yes, correct.
Okay, sir. Okay, understood.
Sir, one question.
बोलो.
Are we going to cover reaction injection molding DCPD technology?
Pardon, please. What?
Are we going to cover that reaction injection molding DCPD technology?
Yes. Don't worry. I am covering that also. Don't worry.
Okay.
Yes. Don't worry, friend. I am covering many things.
One more thing, sir. One more thing. Right now we are covering that processing of plastics.
Yeah.
Any good book you are recommending?
Good books. There are, that Bredson is there. Then the polymer science by Bilmier, and injection molding by Dr. Yemi Joshi. Right. That book is also good. Dr. M. Joshika, then there are some books, right, in the market. The SciTech, it is a publisher. They are, that they have that some list of polymer book. If you see SciTech, SCI Tech, TECH, वो website आप देखो, there are number of polymer processing books are there. SciTech.
Okay, sir.
Yes. We will meet friend tomorrow. Don't worry, right? And have a good night today.
Thank you, sir. Bye.
Bye. Bye.